Students, welcome to lecture number 17. So far we have discussed about different kinds of machine learning models and we are carrying forward that. In the last part, in the lecture number 16, I started discussing about clustering. I hope you have learned the description of clustering as well as the mathematical derivation which is required for K-means clustering problem. So, today we are going to talk more about that and subsequently we are going to discuss about hierarchical clustering, which is something very important for informatics problems. So, you have understood that the machine learning models we have been discussing in details has different aspects of the machine learning models. So, most important thing in clustering is to group the data, but how do you group the data? You group the data based on some similarity. That is what is very important, how to find the similarity, right. So, method is defined in such a way that we can use unlabeled data, because this is a part of unsupervised learning, and idea is to form homogeneous groups, so that they have similarities. So, your starting data may be heterogeneous and then you split the data into different homogeneous groups. So, as I said, how to evaluate the similarity? Similarities are always evaluated based on some distance matrices, like Euclidean distance between the points, or Manhattan distance, or some other parameters like cosine similarity, and then we can actually put these data points together in such a way that they have a high similarity score. A similarity score is basically based on the distance we calculate, right. So, ideally speaking, that is the way clustering is done, especially the K-means clustering is done. So, now there are different types of models exist for clustering. First model we discussed in the last lecture is the centroid models, what is also popularly known as the K-means algorithm. You can also have connectivity models. We are going to discuss in detail about that today, or what is known as a hierarchical clustering. Remember, hierarchical clustering is very important for the splitting the data into different clusters. And finally, one can also have what is known as a distance or density based models. They can talk about spatial clustering problems, or you can have distribution based models also. You can use some kind of a distribution matrix, like different kinds of distribution matrix can be Gauss distribution, Gauss normal distribution, or other distribution matrices can be used also. Well, so as I told you, K-mean square algorithm comes under the centroid based models, and we always talk that one as a flat algorithm, because it ideally start with a random partitioning of data. It does not really talk about very specifically certain aspects of the splitting of data. It starts random clustering data, and that is why it is called flat algorithm. You can also have these hierarchical algorithms where you can divide data based on hierarchy, right. We know hierarchy, right, parents, son, daughter, that is what is called hierarchy, and that can be also two types, a bottom up or a top down. Bottom up is always known as a agglomerative, and top down is known as a divisive approach. You can divide from top and go down the level. Then we talked about hard and soft clustering. I do not want to go into details of that. Again, basically hard clustering means each data point belongs to a particular cluster only, completely it is belong to that. So, but in soft clustering we can always assign a data point to different set of clusters and tell what is the probability of likelihood of a particular point to be part of cluster 1 or cluster 2 or cluster 3, right. So, that basically means that a point can be part of different clusters depending on the probability of likelihood of that point to be belong to the particular cluster. But in hard clustering you can't do that. We simply assign the point to a specific cluster and say that it is only for that cluster, it cannot be part of any other cluster. Well, as you know, taxonomy of clustering is basically like this. You can have hierarchical clusterings, which is possible to have a single link between the hierarchies, or you can make complete link also between the hierarchy is possible, we will talk about it. And then you can have what is known as a partial clustering, that is where the k-means comes in the picture. You can always talk about distance between the points, you can use graph, you can use mixer resolving capabilities or mode seeking capabilities. Remember, we are not going to discuss all these things. Expectance maximization is one such algorithm which is widely used for partitional clustering also. So, but for the time being we are focusing on k-means, and that is what I discussed in the last lecture also. So, in a clustering problem, what is the ideal thing possible? So, what you do is very simple. You have a collection of unclassified data and you have to find a measure of similarity of the objects. We find by distance matrices and then separate these data points in different clusters. Essentially, it is an approach to discover a useful summary of the data, if you look at carefully. That is what we do. Now, you can also have, you can bring in semantic explanations also, like in NLPs, or in other words, you would also can define clusters as some general rules or numerical basis also, that is also possible. So, in a centroid approach, we always guess the centroid or central point of each cluster at the beginning, and that guess is random, remember this. So, once you guess the central cluster point, and then you can find out the nearest neighbor distances from the centroid, and then put the points into part of a cluster, or that make decision whether that particular point is a part of this cluster or not. But in case of hierarchical clustering, we do not do that. We begin assuming each point is a cluster, remember that. So, in centroid cluster, we are defining for the centroid of the cluster. Okay, we can have random choice of centroid. I described you the mathematical part. So, that central point is basically an random, and then you calculate distance of all the points in the clusters from the centroid. The distance matrix can be different kinds of formally possible, but you calculate the distance depending on whichever matrix is useful for you for that particular machine learning problem. So, once you calculate distances, then you make a similarity matrix that I already discussed about it a lot. I do not want to go back to board, you can look at the lecture which is given in lecture number 16. But in hierarchical approaches, you do not do that. You basically begin assuming each point as a one cluster by itself and repeatedly then merge the nearby clusters. Obviously, you have to use certain matrix or measure, and that matrix can be distance between the centroids, or you can also use how good the cluster, how good a cluster resulting would be, like average distance of points in the cluster from the resulting centroids. There are many matrices exist, okay, that can be always devised, that is not a big problem. So, as I told you, centroid based clustering are basically partitioning methods. You can also have density based clusters, how many number of points in a particular region can be defined as a density, and you can define that. You can also have a connectivity, we will talk about it, or distribution like normal distribution. So, binomial, Gaussian, other distributions. Okay. So, point to be noted is that in centroid based clustering, the distance matrix can be different types, Euclidean, you can see that it can be Euclidean, it can be Manhattan type, or it can be Minkowski type also. And this distance formulae are used to calculate the distance of any point from the arbitrarily chosen centroid, and then we can decide about that. So, that means what? That means we are finding a vector between the centroid, which is arbitrarily chosen, and any point in the cluster. So, then you decide from the similarities of these vectors whether that point can belong to that particular cluster or not. But in case of density clusters, we calculate density of data points, right. Here we are calculating number of points basically. That is why they are very sensitive to the initialization, and and it determines the clusters automatically. Okay, remember this determine the cluster automatically, it does not talk about any problem on that. We can determine the cluster automatically, otherwise it can also, it is that is why less susceptible to the initialization, okay, so beginning positions. In connectivity clusters, basically each data point is initially taken into account as a separate cluster, and then you bring this connectivity. Remember, I talked about connectivity some time back. single link connectivity or complete link connectivity. What is important we have discussed about, we are going to discuss about detail about that. And distribution is basically different distribution functions. So, let us not talk about it. So, I first described to you the k-means clustering problem is basically what is the widely used one, and this is very fast compared to other clustering techniques, and it provides a strong coupling between the data points. That is why it is so widely used, and it do not provide any clear information about the quality of the clusters. That is very one of the weak points of k-means clustering algorithm. So, distance can be different types. Common distance is what is known as L2 norms, that is nothing but a Euclidean distance. You can always take like that. Let us say I will also explain this. So, this is x, this is y. So, this will be what? Root x square plus y square, right? That is what it is. So, if you have different sets of points, you have different sets of points like this. Let us say this is your centroid, and you have different sets of points like this. Okay. So, basically what do? You calculate distance like that. This is a coordinate geometry. So, centroid let us say 0 0 point, and this is your xy point. So, basically root over x square plus y square distances, right. So, similarly you can define the distance of this also. This you can put x1 y1, and it will be distance will be root x1 square plus y1 square, right. That is one way of calculating distance. Then you can also calculate the Manhattan distance. This is nothing but L1 norms. Here you do not take the square, but you take a absolute value distance differences between these two, right. So, this is x, this y is basically take a absolute of x minus y, right. That is what is very important. So, Manhattan is widely used, remember this. Many of these material science problems where you use clustering is required, we can use Manhattan distance as one of the important distance matrices, or otherwise you can use the max of dimension, whichever is max, right. That is what is shown, right. So, here you can see out of these two, this distance, red color distance is max. So, x is max compared to y, that is y. Okay. In fact, if you do that also, this root over x square plus y square also will be lower than x, correct. So, you can do that also. So, this is what is the this slide you must look at very carefully. This is what I am giving you all the formulae of different distance matrices. The first one is Minkowski, and then the Euclidean, all of you know. Manhattan. Manhattan is also known as a city block. Okay. It is came from the how the city structure is developed, distance between the two buildings in a city. You can use Canberra, Chebyshev, quadratic, Mahalanobis. Even you can use distribution function x square or candle rank correlation also. It can be using any of these formulae, but in material science we normally use Minkowski, the Euclidean, Manhattan, Mahalanobis more. Okay, they are talk about it, but many of these distance matrices you have to really know how to calculate. Like in case of Mahalanobis, you need to calculate the covariance matrix and then do that, the V transport covariance matrix, and also you have to calculate the determinant of that V and take care of this. Okay, these are little bit complex, so you can look at in internet or books also how to calculate that. So, let us talk about a little bit more on the k-means. We can have k cluster centroids, you can have randomly choose that and assign the points to cluster by picking the closest centroid, very simple. Okay. So, if I have, let us say I put a centroid here, so I can clearly see the closest point is this, right. So, you can even calculate the distance, you can clearly see that this is what the closest point. So, it looks like that this distance is the closest one. So, therefore, that we can easily put into these clusters, and slowly you can do that for the other points also. So, in reality for k-means clustering there are two parameters we need. I talked about in the last lecture. So, you need this is what is called centroid or mean, and you also need to know R&D, right. So, as you have seen, the real problem, real aspects of this function which you are going to do is very simple. The j, this is what is called the objective function in k-means square. What is the objective function? Is basically nothing but sum of n goes to 1 to n goes to 1 to n, 1 to capital N, and k also goes to 1 to k, then r n k. This you have to take mod x n minus mu k square, correct. So, these two parameters, one is your r n k, I marked it here, other one is this. These two are the important parameters which requires optimization. This is basically rank we call, or in case called rank. Okay. So, we have determined these two, we can simplify that, and that is why many people write this and this are the important parameters for k means algorithm. Okay. So, please keep in mind that these two are very important. So, that is what is shown here. So, in a cluster assigned matrix you can always do that. You can see there are many centroids, data points are like that, and you can keep on repeating that, and finally, you can update the step. But one aspect you have to remember in this formula. So, R n k is basically determined, very simply by this way. Let me write down R n k is can be written as 1 if the, what is that called, if k is what, argument minimum of j, or minimum rather, is what is called x n minus mu k square, otherwise it is 0. I explained you in the last lecture. So, that is how R n k is determined, but mu k is more important also, because that is what talks about the mean values. So, how to initialize the k centroids? Pick points sufficiently far away from the other centroids, okay, until there are k centroids sufficient. This is one way of initialize the k centroids. You can choose points sufficiently far away from each other. So, as the computation progresses, one can decide to split one cluster and merge 2. So, the total number remains k. A test for whether to do or not can be to ask whether doing so reduces the average distances from the point to the class centroids. This is one of the tests. You can actually calculate the distances, average distance from the point to the centroids. This is a test. So, you may split after you decide k centroids, you may split even one cluster into 2 clusters. So, then you will increase k to k plus 1, right, or then you have to also merge other places 2 clusters. So, that one addition can be removed when you merge 2 clusters. That is why k can be completely 10 such that. So, once you having located these k clusters, you can say reassign all the points, as I told you, by simply using this mathematical formulae, and wind up this whole problem. That is what it is. So, let us start the hierarchical clustering problem now. What is hierarchical clustering problem? This is a connectivity based algorithm, remember this. And so, what does it do? This kind of clustering models group the data point together that are close to each other based on the measure of similarity of distance again, but their connectivity. So, assumption is that data points that are close to each other are more similar or related to the data point that are farther apart. So, in doing so, we have to create something known as a dendrogram. We will talk about it. It is nothing but a tree like structure, like a decision tree, right. It is produced and it depicts all the hierarchical relationships. Family tree is one such example. In a family tree, we have a tree like structures starting from grandfather to father to son or daughter like, and then it goes on. So, exactly same thing, dendrogram is like that. It is a tree like structures, and that retains the connectivity of the hierarchical clusterings. Individual data points are located at the bottom of the dendrograms, okay, just like a decision tree, your leaf node is where things ends. Similarly, here also individual data points will retain at the bottom of the dendrograms. For the largest clusters, which may include all the data points, we will look at the top. So, you have to generate different type numbers of clusters. Dendrograms can be sliced even at different levels. So, give an example. Imagine you have 4 fruits of different weights: apple 100 grams, banana 120 grams, cherry 50 grams, grape 30 grams, right. So, how do you do a hierarchical tree-like structures? Correct. So, you have fruits, right, they are all fruits. Then you have 4 branches, one is called apple, banana, cherry, grapes, because based on the weights. Remember, these are all different fruits. So, they have no similarity, taste wise also, looking wise also, right. So, that is how we can actually generate that. So, you can write apple here, you can also write banana, then cherry, and finally grape. Then you can also divide in terms of weights. So, you can clearly see with this also 4 parts. Apple is the heaviest one, 100 gram. Then you have, sorry, apple is not the heaviest one. Heaviest one is banana, right, 120 grams. You should be careful. 120 gram, 100 gram, 50 gram, and 30 gram. So, you can divide, you can create this hierarchical clustering like this way. One is based on the fruits, other one based on the weights. So, basically technique to group similar data points. So, what is the similarity? Apple is one kind of fruits, banana is another kind. You cannot compare them actually, they are not same. So, that is why it can create a tree-like structures. Key idea is to begin each data point as its own separate clusters. That is the key idea in hierarchical clustering. Remember this. You consider each data point as its own separate clusters, and then progressively you can merge or split based on the similarity or dissimilarity. Okay. To give an idea, these are different kinds of subjects, right. I did not write the subject, I thought you will tell me that. So, this is subjects. So, you have agriculture, biology, physics, computer science, space, correct. So, as you can clearly see, agriculture has dairy, crops, forestry, agronomy, they are separate subjects. Biology has botany, cellular biology, evolution biology, physics has magnetism, relativity, CS has AI, HCI or other courses, space can have craft, spacecraft or space mission or many others. Am I clear? So, you can do that actually. So, this is how hierarchies are made, and these are the connecting links, you can see that. Forget about these numbers, they are talking about something else, but this is how the hierarchical clusters are developed. So, basically it talks about a tree based hierarchical taxonomy, or what is known as a dendrogram. Am I clear? Remember this word dendrogram, it is just like a dendrite kind of structures. So, you have animals, 2 types, vertebrate, invertebrate. Vertebrate you can have fish, reptile, amphibial, mammals. Invertebrate can be worm, insect, crustaceans, right, all kinds. Then you can fish, you can have different types, reptile can be different types, or like that. Am I clear? That is how we can actually create this taxonomy, what is known as a dendrogram like structures. Am I clear? You please understand that. So, what is the difference between clustering and hierarchical clustering? In clustering, what you are doing? You have a data points, right, random. So, in clustering you are creating similar set of points. So, what you do in K-mean clustering, you are putting some kind of a centroids, calculate distance of the point from the centroid and putting as a cluster, right. So, you can do that. Similarly, here also you can do that, right. Here also you can do that. Am I clear? So, these are different clusters according to me. According to the whatever slide I have drawn, it is different. Sorry, it is different, right. This is one cluster, this is another cluster. So, you can have many clusters, as many as clusters possible. In hierarchical clustering, you do not do that. What you have to do is you have to create these connectivities, connecting links. So, you can see you have E1, E2, E3, E4 up to E8, they are all connected, some means, some way or others, right. So, E1 has only how many? E1 is this big cluster, it is consisting of E3, E4, many other points, right. They are all connected, right. You can see that E1, E2. Then E7, E8 is this part of this cluster, which are part of E2. That is what E2 has these connections. So, E1 is basically I can write down E3, E4, right, and this is your E. So, you understand that we have to find out these links, connectivity links for that. So, basically first this I had already discussed about it. So, basically it creates a dendrogram at the end of the day. So, let us stop out here and we will come back and discuss about dendrograms and other aspects of dendrogram in detailed manner, so that you can understand it.